Okay, Assalamualaikum and hello everyone. So today's kita akan masuk chapter yang baru, which is chapter 2, capacitor and dielectrics. So for the 2.1, in this chapter we have 3 subtopic. So today kita akan masuk subtopik yang pertama 2.1, capacitance and capacitors in series and parallel. Okay, so you see here we have two things you need to know. The first one ialah capacitance and the second one is capacitors. Okay. Learning objective 2.1a, you need to know how to define and use capacitance. Okay, so apakah capacitor? Capacitor is a device that able to store electric charges or electric potential energy. So capacitor dia ialah device, it is benda tersebut, okay, alat tersebut. So this is the capacitor. What it's going to look like in real life, ini ialah capacitor. It consists of two conducting plates separated by a small air gap or a thin insulator called dielectric. Okay, as mentioned here, dielectric can be mica, ceramics, paper or even oils. Okay, the symbol for capacitor is like this or like this. We usually use this symbol here. Okay, so from here it said that a capacitor consists of two conducting plates. So dia ada two conducting plate in real life. Okay, two conducting plate which separated by air ataupun a thin insulator. So boleh jadi tengah-tengah dia ni ialah air sahaja, kosong, udara ataupun vacuum, dan boleh jadi kita letak material here which is we call as insulator. Okay, so insulator ni boleh jadi anything yang dia tak boleh mengalirkan arus elektrik. So it is insulator. So dia ialah biasanya kita letak dielectric. So dielectric can be mica, ceramics, paper or even oil. Okay, okay, that is capacitor. Dia ialah device. Capacitor ni dia device. And what is capacitance? So capacitance is the ability of a capacitor to store charge is measured by its capacitance. So, capacitor is the device. How the capacitor can store charge, itu sebanyak mana dia boleh store charge dalam capacitor ini, itu ialah capacitance. Okay, so fungsi capacitor, dia boleh store charge. Okay, sebanyak mana charge yang dia boleh store, kita nilai, kita measure menggunakan capacitance. Okay, so capacitance is the ratio of the charge on either plate to the potential difference between them. So dia mention dekat sini on either plate, salah satu plate saja, sebab capacitor dia ada dua plate, plate 1 dan plate 2. Tapi dia punya how to calculate capacitance, dia ialah ratio of the charge on either plate to the potential difference between them, or C is equals to Q over V. Okay, so C is equals to Q over V. As we know, Q is the charge on one of the plate. Satu plate sahaja. Dia bukan both plate. Okay, on one of the plate, and the unit for Q is coulomb. V is the potential difference across the two plates. So where is the potential difference? So we have two plate here. Ini plate 1, ini plate 2. So the jarak antara these two plate is the potential difference. Okay, so itu ialah V. And the unit for potential difference is volt. Okay, so the charge stored is directly proportional to the potential difference. As we know here, C is equals to Q over V, and CV is equals to Q. Alright, so dia kata the charge stored Q is directly proportional to V. So the charge stored is directly proportional to the potential difference at a constant C from this equation. Right, and it is a scalar quantity. Kalau scalar quantity, it only has the magnitude, and the unit for capacitance is farad. Okay, or coulombs per volt, but we usually use farad as the unit for the capacitance, and it is always a positive quantity. Okay, and we go to one more, learning objective 2.1b. You need to derive and determine the effective capacitance of capacitor in series and parallel. Okay, so you have already known what is series and what is parallel. Okay, as we show here, we have three capacitor C1, C2 and C3 and dia berada dalam keadaan series. How we want to know it in series? Kalau kamu tengok, satu sahaja kaki C1 bertemu dengan C2. Sebelah sahaja. C2 sebelah kaki bertemu dengan C3. Meanwhile, kalau kamu nak tahu dia ialah parallel, C1 punya kaki dua-dua bertemu dengan C2. Dua-dua kaki C2 bertemu dengan C3. So both leg meet to the same capacitance. But if it is in series, sebelah kaki dia je yang bertemu. Alright, that's how I differentiate between series and parallel. Okay, so before that, a capacitor in series, we have three capacitor here, C1, C2 and C3. So, bila dia berada dalam keadaan series, the charge on all three capacitors are the same. So, dekat sini, C1 akan ada Q1, akan ada Q2 dan akan ada Q3. Both of the capacitor charge in C1, charge in C2, charge in T3 are the same dengan Q total. Alright, so charge-nya sama, but the potential different across capacitor, dekat C1 akan ada V1, V2 dan V3, dia tak sama, tetapi dia ialah hasil tambah dan nilainya sama dengan nilai bateri dekat sini. So supply voltage, this is the supply voltage, V yang kita bagi, nilai dia sama dengan hasil tambah 1, 2 dan 3. Right? So dia hasil tambah. Okay, so what about the C effective? Okay, C effective also can be called as C equivalent. So how do we want to get C effective? C effective untuk series dia ialah 1 over C effective equals to 1 over C1 plus 1 over C2 plus 1 over C3. So C effective ni ialah the combination of these three C. Okay. How you want to get this? Okay, before that, you have to know this is 1 over C. To get the C effective for series, we always use 1 over C1 plus 1 over C2 plus 1 over C3 to the power of negative 1. Sebab yang ini dia 1 over. Okay, so I always use this one. Right? Okay, so how we get this equation? Okay, so kita tahu tadi, V dia hasil tambah. V total sama dengan V1 tambah V2 tambah V3. And kita tahu V is equals to Q over C. From equation C equals to Q over V. Okay, so bila kita gunakan this equation, kita substitute je dalam V, kita akan dapat Q over C, Q1 over C1, Q2 over C2, Q3 over C3. Disebabkan Q-nya Q yang sama, kita boleh keluarkan dan kita cancel, kita akan dapat 1 over C sahaja. Okay, so how this is how we get the equation for C effective. Okay, so you have to know this one, the charge, the potential difference atau and the effective capacitance. This is not given. Alright, so this is for series and for parallel. Okay, so parallel kamu tengok C1, dua-dua kaki dia bertemu dengan C2. Okay, and C2, dua-dua kaki dia bertemu dengan C3. Okay, alright, that's how we differentiate between series and parallel. Alright, so for parallel, dia lain sikit dengan series. So, untuk parallel, charge-nya ialah hasil tambah. Okay, dekat C1 akan ada Q1, akan ada Q2, akan ada Q3. So, Q totalnya ialah hasil tambah 1, 2 and 3. Dia dah tak sama. Okay, but the potential difference across each capacitor is the same as the supply voltage. So, this is the V supply. So, V supply sama dengan V1 dekat sini, sama dengan V2, sama dengan V3. So, V dia yang sama. 1, 2, 3. Kalau 10 volt kamu bagi dekat sini, kat sini semua ada 10 volt, 10 volt, 10 volt. Right? And the C effective ialah hasil tambah. So, C effective is equals to C1 plus C2 plus C3. So, how we get this equation? Untuk parallel, kita tahu juga Yang tambah ialah Q, and we know Q is equals to CV. From equation C equals to Q over V. So kita just substitute CV dalam equation Q yang ini, kita akan dapat this one. Dan kita tahu V-nya V yang sama, we can cancel all the V. So what left is this equation. So kita dapat C efektif untuk parallel ialah C1 plus C2 plus C3. Okay, so you have to know the differentiate between series equation and parallel equation. Right? So the third learning objective for today ialah 2.1c. We have to derive and use store energy in a capacitor. Ini di muka surat 7 nota kamu. Okay. We need to know how to derive and use energy stored in a capacitor. Sebab fungsi capacitor ialah store charge. Store charge, it can store energy. Okay. So a charge capacitor stores electrical energy. Okay. Capacitor yang dah di-charge, dia boleh store electrical energy. The energy stored in a capacitor will be equal to work done to charge it. Okay, so how we want to get the equation? When the switch is closed, okay, kita ada, this is our capacitor, this is our voltage, supply voltage. Okay, bila kita closekan switch kita, charge begin to accumulate on the plate. So, electron akan keluar. So, elektron akan keluar daripada negatif, this one akan keluar pergi dekat kita punya charge. So, that's why this one jadi negatif. A small amount of work is done in bringing a small amount of charge from the battery to the capacitor. So, nak gerakkan the electron, kita perlukan work done. So, elektron ni kecil. So, work done pun kita guna a small amount of work done. Okay. So, how you want to derive? Okay. So, kita tahu from the equation in chapter 1, work done, potential difference is equals to work done over charge, and kita tahu V is also equals to Q over C. Okay, so W, kita tahu work done is equals to VQ. Disebabkan kita menggunakan a small amount of work sahaja, we have to integrate dia. Okay, integrate W in term of W, kita akan dapat dW dQ. Right? So, integrate 1 in term of W. Ini 1 kan? 1 in term of W, kita akan dapat W. Integrate V in term of dQ. Tak boleh. So, kita tahu V is equals to Q over C. Kita substitute sahaja. Integrate Q over C in term of dQ. Kita akan dapat W is equals to 1 over C Q square over 2. Okay, so ini ialah work done. Kita dapat this equation. And equation ini kita boleh susun menggunakan this one. So, kita akan dapat work done is equals to half Q square over C. Then, from work energy theorem, W is also equals to U, which is energy stored. Untuk kes kita hari ini, U is the energy stored. Simbolnya ialah U. So, U is equals to half Q square over 2C ataupun half CV square ataupun half QV. Yang dua ini, kita boleh derive from equation C is equals to Q over V. Kita susunkan sahaja. Okay. So, this is the formula for energy stored in the charge capacitor. Okay. B, from the formula above, the energy stored in a charge capacitor is half the energy produced by the battery. Kenapa? Okay, so if the energy produced by battery, the formula is U equals to QV, and the energy stored in a charge capacitor is ialah U equals to half QV. Okay, so energy loss, akan ada energy loss semasa proses pergerakan charge kepada capacitor, dan energy itu loss dalam bentuk heat. Okay, so energy produced by the battery tolak energy stored in a charge capacitor, kita akan dapat energy loss, which is the energy loss ialah heat. Maksudnya, kalau bateri itu bagi 10 joule, energy produced battery is 10 joule, energy yang boleh store dalam charge capacitor ialah 5 joule saja. Dia ialah half daripada energy produced. Okay, mana lagi hilang? Dia hilang dalam bentuk heat. Okay. So, that's for 2.1.